8, graph linear inequalities in two variables. So some of them we're going to actually be graphing. Some of them are going to just ask you if the ordered pair is a solution or not. So these first ones, they just want us to tell if the ordered pair is a solution. So number 4, we have the equation y is less than or equal to negative 5x. And then we have the pair 3, 2 and negative 2, 1. So basically we're going to be doing this like twice. So I've got 2 is less than or equal to negative 5 times 3. So 2 is less than or equal to negative 15. Well, is that true? No. So we would say not a solution. Then I'll do the same thing but with the other point. So I've got 1 is less than or equal to negative 5 times negative 2. 1 is less than or equal to 10. Well, that's true. So this one is a solution.
That's easy.
So the whole point behind us doing this is that when you get to your graphing and we're shading, you can take a point in your shaded area and confirm if you've done it correctly or not by plugging that point into your original equation, and it'll tell you, like, if it's a solution, then you've shaded correctly. If it's not a solution, then you need to shade the other direction. I don't require you to check, but it is beneficial to, so that you don't shade in the wrong direction, because most people can graph it, but then they shade it the wrong way if they're going to miss points on this. So just be aware of that. All right, number 8, x is greater than or equal to 6. So just as a reminder, if it's a greater than or equal to or a less than or equal to, we have a solid line. If it is just greater than or just less than, it's dotted. If you accidentally do a solid line and it's supposed to be dotted and you like realize it after the fact or something like that, draw an arrow to it and just write dotted. Okay, now don't do that on every single one, but obviously you're using pencil, you would be able to erase relatively easily. But if something happened, more so when we get into solving like systems of them in chapter 4, no, actually it's in chapter 3, then that's where you might need to do that, but just so that you're aware. All right, so I'm going to set this up, maybe. So what would this graph like look like? Not like shading and all, but how would I graph this?
Wouldn't the line be on 6?
On what 6?
Positive 6 on the x-axis.
Yep, on the x-axis, I'd go over to 6.
And you would shade everything to the left of it.
Right. Over here.
Because it's greater.
Greater
So
than.
you go to the right, you go to the greater side.
Oh.
Should be shaded on this side.
Oh yeah, great. I didn't see that. Oopsie.
And I can check by plugging in a point. I could plug in the point 8, 0. Well, if I plug in that 8 for x, 8 is greater than or equal to 6, so I'm good. If you want to use highlighters to shade, that's fine. If you want to use your pencil, you can obviously do something like that. That's sufficient for shading, but however you want to do it.
Yeah, every square inch. It has to be like this pencil.
Oh wait, not 10. 12, I lied. We're doing 12, not 10. 12 is too much like the one we just, or 10 is too much like the one we just did, so I'm going to do 12. All right, y is less than 3x plus 3. So if it's helpful to you, before you ever graph it, you could go ahead and write what's going to be happening. So if I was going to do that one, I could say that, well, this is just less than, so it's going to be dotted. And I could also say that, well, y is less than all of that, so that means it's going to be shaded below. So if you want to, you could go ahead and like write that stuff down so that you make sure you do it the right way, but you do not have to. That's not like, if you don't do that, I'm not taking off points or anything like that. All right.
So wouldn't it just be slope intercept?
Yep, so you just graph this like a normal equation of a line.
Oh, it's just graph. Extra steps.
Yep. Basically, we just need to make sure that we pay attention to the fact that this one's going to be dotted. So I've got a y-intercept of 3. I've got a slope of positive 3, but I don't really want to make my graph any larger than it is. So I'm going to go down 3, back 1, because it'll still keep my positive slope. And then down another 3 and back 1. If you want to make your graph large, you're welcome to do that. So this is dotted because it's just less than. So I'm basically just going to do a dotted line like that. If I accidentally did it solid, then I would just do something like this and I would draw an arrow and I would put dotted like that so that it's clear that it's supposed to be dotted. Okay. Or if you feel like it's hard to see, you can also write that just to make sure, whatever. All right, so this one is shaded below. So it's kind of hard to see below on this one, right? Because it's just slanted. But it's where the y values are smaller. Okay, so the y values are smaller down here. So I'm shading down here. And again, I could check a point. I could actually check the point 0, 0 on this one. So if I plugged in 0, then I would have 0 is less than 3 times 0 plus 3. Well, 0 is less than 3, so I know I've shaded it correctly. Okay. Again, you do not have to do that, but if you want to confirm that you're shading in the right spot, you can do it that way, which is the whole point of the first problem that we did. 14. Y is greater than or equal to negative 2/3 x minus 2. So what's going to be true about this graph?
Yeah, it's going to be a solid line, and
Yep.
it's going to be above the y.
Yep. Solid and above. I usually like to note that because inevitably I graph solid and dotted wrong. Well, I'd graph everything solid just out of habit, and then I have to go back and fix it. So I like to go ahead and note early what's happening. All right, so I have a point at negative 2 on the y. And then what does my slope tell me that I need to do?
You go down to right 3.
Yep, down 2, right 3. Or,
2 left.
yep, up 2, back 3. This is solid, so I can just connect my dots.
Good job.
You did. And then you shade everything above.
Yep, shade everything above. It's my favorite part. One more. 16. X plus 4y is greater than negative 12.
Oh, wow, they don't make it into what you call.
So we're going to have to manipulate it, yes, to be in y equals mx plus b. So I need to subtract the x first. So 4y is greater than negative x minus 12. Divide by 4. Y is greater than negative 1/4 x minus 3. I know, I was like, can we not? Turn this off. Now, the one thing I will caution you about, if that had been a negative 4y, what would I have had to do when I divide it? Yep, I would have had to flip the inequality, which means that the shading would be in the opposite direction. So don't determine which way you're shading if it's not already in y equals mx plus b. Okay? Wait till after. Now, some people would say, well, why can't we just use intercept form and like do the cover-up method and graph the points that way? You'll probably end up shading it the wrong direction if you do it that way, unless you're like checking points to see. So I would just say get it in y equals mx plus b and go with that way. All right, so what's going to be true about this graph?
Everything above the y and it's dotted.
Yep. So it's going to be above and dotted. All right, so I've got a point at -3. What does my slope tell me to do?
Down one, right 4, or you can go up.
Down 1, right 4, or up 1, back 4. The other reason I probably wouldn't have used intercept method with this one is because, aside from the shading issue, is that would have had x being out at -12 and my graph would have been excessively large. Not that that's a problem, but I would prefer not to take up my entire paper. So, dotted. Whoa, that's not, hold please. It's definitely not straight, but that's okay. And then it's shaded above, so that means up here. And again, I could check 0, 0. I would probably recommend you check it in the original equation, just to be safe rather than the bottom one. But if you've had to flip the sign, you may need to check it in the final one. But if you're not sure if you like did your math right, I would check it in the first one. It should still work either way, but just be aware of that. Okay, any questions about this stuff? There are like absolute value inequality graphs, and basically you'd either be graphing inside the V or outside of the V. We don't do anything with that because, one, I cannot think of a time past this section where you would ever use it. However, when we get to parabolas in chapter 4 and we're graphing those, we will graph inequalities with parabolas as well. So we'll kind of hit it when we do that, and it'll be like you'll either shade inside the U or you'll shade outside the U. So just as like a heads up. But this is all we need out of this section. Whoa. So problems. 5, 9, 11, 13, and 17. So, not a whole lot. You should have plenty of time to get them done. So tomorrow we'll do review for the quiz that's on Monday. We'll just have a few review problems to do, and then Monday we'll take the quiz, and then we'll basically have whatever's left on Monday, and then Tuesday to review for your test on Wednesday. I will do my best to have your quizzes back to you on Tuesday so that you would have them to look at to study off of, or at a minimum at least be able to show you the key for it. If for some reason I can't get them graded in time, shouldn't be an issue, but just in case.
All right.
Time for you to